All right, let's see here. Now we can see that. Whoa, look at that. Not bad at all. But how does this work? Let's find out. Another example is if we use a glass prism here, and since the different frequencies of light, which are coming through the sunlight, coming through the window here, the bluer ones get diffracted at different angles than the redder ones. So when we back up, we can see this angle difference more pronounced. Now you can see there. Try and get a little more sunlight. Look at that, and then you can actually see the rainbow in there. Doing all the colors of the rainbow, that Roy G. Biv, red, orange, green, yellow, blue, indigo, violet. Okay, so how I did this, I took the fish tank, filled it up with 4 pounds of sugar, and just let it sit for several days. And now we have an area where you can see the light at the top, the light just kind of goes straight across. Doesn't really bend at all. But that's because the sugar at the bottom is denser than the sugar water at the top. So it kind of settles out in a gradient of low density to high density. So as we get near the bottom where it's denser, you can see the light actually start to bend. And I'm gonna use this book to set the laser on it so you can see that I'm shooting it straight across. I'm not shooting it down on an angle, being like, oh, look, it bent like that. No, I'm just gonna lay it flat on the book. So you know it's shooting straight across, and you can see clearly that it's bent down there. Now, with the prism example, we had the lights bending at different angles. So I have 3 different laser pointers. I'm going to actually turn the lights out to make it a little more pronounced, because this blue one is really hard to see when the light's on. But when I do all 3 of them together, and I'll do blue, red, green. No, I'll do blue, green, red. I'll do them in that order. I'll shine all 3 of them on. They should all bend at different rates. Let's have a look. Now, light likes to travel in a straight line. And when traveling through a vacuum-like space, there's nothing for the light to hit, so it travels at its maximum speed of 186,000 miles per second. That's really, really fast. So when light has to travel through a transparent medium like water or glass, there are particles in its way, and the light rays have to actually get absorbed by a particle and then re-emitted, and then absorbed and re-emitted. So that's going to slow that down. So we can actually use drawing of light rays as a way to kind of model this. So in a vacuum, light's just going to travel straight across, 186,000 miles per second. If it's traveling through a medium like maybe water, it's going to come, and as you see, it's going to take me longer to draw each individual segment, because the light gets absorbed, then re-emitted, absorbed, and then re-emitted, absorbed, and then re-emitted, and then absorbed, and then re-emitted again. But if we go through a denser material, like let's say glass, this is going to take even longer for me to draw the arrows to go across here. And this is how light gets slowed down when it has to travel through a medium like this. The denser it is, the longer it takes for it to happen. Now, this is a really exaggerated example. Light obviously does this a lot faster. When light slows down, it actually changes direction, but then travels in a straight line in that new medium, in that new material. So here's a picture of a straw in a glass of water as a demonstration. And it's just a regular glass of water, and I just put a straw in it. And because the light gets its direction changed, but then continues to travel in a straight line, that's why the straw doesn't appear to be bent, just displaced when it's in the water. But if we do something like in the fish tank where the density is changing in the material, then we can get it to change direction and actually be bent like that. Let's take a look. Okay, now the lights are off. So here's the blue one. You can see the blue one bending right there. And now here's the red one. That's the green one, sorry. And then the red one. So the red one should deflect the least. The blue one should deflect the most. And then the green one should be in the middle. So when I shine all 3 of them at the same time, we should see them land in different spots. I'm going to line them all up side by side so I can push all 3 buttons together, same distance. Here we go. And look at that, they are all in different spots. I'll try and separate this blue one out a little bit because it is hard to see. Yep, check that out, pretty cool. This green one is just so much brighter than the other ones though. I really like that one the best. So watch, I'll even like kind of prop it up a little bit. You can see it's still bending even as I lift it up. Pretty cool. Hope you enjoyed this. Have a good rest of your day. Just a quick follow-up here. I left this out for another week, and it looks like all the sugar has dissolved off the bottom there. So now we get like a reflection of the light off the bottom. Watch this. Now the light's bouncing off the bottom and curving down as it hits and curving on the way back up due to the different densities of the sugar water in the tank there. Pretty cool. All right, see ya.